Hey class, Mrs. Anderson here. We're going to start out Unit 11, Section 11.1a with some right triangle trigonometry. Trigonometry. There we go. Our objective for this lesson is that we can use trigonometry relationships to evaluate trigonometric functions of acute angles. So we have our standard ones that you might remember from geometry, sine, cosine, and tangent here. And then these ones might be new. These are our inverse functions, cosecant, secant, and cotangent. So we're going to review the 6 trig functions, and we'll also review how to evaluate them. So these are the 3 that might be relatively new to you. Sine, cosine, and tangent should be familiar from previous courses. But cosecant, secant, and cotangent, these are the inverse functions of cosecant goes with sine. Cosecant is the same thing as 1 over the sine of theta. So it's the reciprocal of sine. Secant is the same thing as 1 over cosine theta. And cotangent is the same thing as the reciprocal of tangent. So 1 over tangent of theta. So sine goes with cosecant, which we use CSC to abbreviate that. Cosine goes with secant, and we use SEC to abbreviate that. Tangent goes with cotangent, and we use COT for the abbreviation of that. So 1 over sine of theta is the same thing as the cosecant of theta. 1 over cosine of theta is the same thing as the secant of theta. 1 over tangent is the same thing as the cotangent of theta. So theta is a Greek symbol, and it represents an angle in degrees. So we use this, it's a Greek symbol, and we use it to represent an angle in degrees. So represent an angle in degrees. So now we're going to look at the ratios. If we look at a right triangle, what are the ratios of these trig functions? And you might have heard this acronym before. We use Sohcahtoa. So Sohcahtoa. And it helps us remember the ratios of the sine, cosine, tangent function. Sine is opposite over hypotenuse. That's where the so comes from. Sometimes you see it written like this, opposite over hypotenuse. Cosine is adjacent over hypotenuse, sometimes written like that. And tangent is opposite over adjacent. So those are our trigonometric ratios of side lengths for our theta. So if our theta in the triangle is right here, then the side across from it is the opposite side. The side next to it is adjacent. Adjacent is another word that means adjoining. So adjoining or next to. So the side that touches it is adjacent. And then the hypotenuse is always the longest side. And it is always opposite the right angle. So we're looking at right triangle, and it's always opposite the right angle. So then sine of theta, we use Sohcahtoa to help us remember, but sine of theta will be the opposite side over the hypotenuse. Cosine of theta will be the adjacent side over the hypotenuse. And tangent then is the opposite side over the adjacent side. Now remember, cosecant, CSC of theta, goes with 1 over the sine of theta, which would be 1 over opposite over hypotenuse. So if we had 1 over a fraction, it would be the same thing as multiplying by that reciprocal, so 1 times the hypotenuse over the opposite. So this ends up being our ratio for cosecant. So if the sine is opposite over hypotenuse, the cosecant will be the hypotenuse over opposite. And the same is true, the same argument can be true for secant and cotangent. So they're the reciprocals. So if cosine is adjacent over hypotenuse, secant is the hypotenuse over adjacent. And cotangent is the reciprocal of tangent. So if tangent's opposite over adjacent, cotangent is adjacent over opposite. So knowing these ones will help you be able to find the reciprocal functions, and then just remembering that cosecant goes with sine and cosine goes with secant, or secant goes with cosine. I think I said inverse in the beginning, but it's reciprocal is the word I was looking for, not inverse. So let's look at example 1. We're going to evaluate the 6 trig functions given this right triangle with side lengths 5, 12, and 13. So here's my theta. So then the side across from it is going to be my opposite. The side that's adjoining, or the side that's touching, is going to be my adjacent side. And then the side across from the right angle is your hypotenuse. So labeling those first. And then if you remember Sohcahtoa, Sohcahtoa. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So sine then will be opposite over hypotenuse, or 12 over 13. Cosine will be adjacent over hypotenuse, so 5 over 13. Tangent is opposite over adjacent, so 12 over 5. Cosecant is the reciprocal of sine, so that will be hypotenuse over opposite. Secant goes cosine, so that's hypotenuse over adjacent. And cotangent will be adjacent over hypotenuse, the reciprocal of cotangent. So this one is 1 over sine of theta, this one was 1 over cosine of theta, this one was 1 over cotangent of theta. So the reciprocals. Okay, here we're going to evaluate the 6 trigonometric functions of the angle theta shown in the right triangle. But you might notice that we're missing the hypotenuse. So if you recall, we have a formula called the Pythagorean Theorem that tells us if we have any right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse, which means that the formula is a squared plus b squared equals c squared. So the legs squared, if you add those up, it equals the hypotenuse squared. So in this example, we can find the hypotenuse by taking 5 squared plus 10 squared equals our hypotenuse squared, or our c squared. So then that'd be 25 plus 100 equals c squared. So 125 equals c squared. And to finish solving for c, I would take the square root of both sides, and we would get c equals the square root of 125. Now, I should be able to reduce that, since 125 is 25 times 5, and 25 is a perfect square. So the square root of 25 is 5, and there's a square root of 5 left in there. So my hypotenuse is going to be 5 square roots of 5. And I know that's my hypotenuse because it's across from the right angle. This is my theta again, so the side opposite will be my opposite side. The one next to it is going to be my adjacent side, and then 5 square roots of 5 will be my hypotenuse. Using Sohcahtoa, or you can write it like this with the kind of built-in fractions. It kind of helps students remember it one way or the other. Sine will be opposite over hypotenuse. So the sine is going to be 10 over 5 square roots of 5. Now we do need to use a little bit of our algebra skills because we can't leave the square root in a denominator or fraction. We have to do what's called rationalizing the denominator. So recall we'll have to times this by the square root of 5 on both the top and bottom. So on the top I'm going to get 10 square roots of 5, and on the bottom I have a 5 there, and then square root of 5 times 5 is 5, so we have another 5. I'm going to have 10 square roots of 5 over 25. And then 10 over 25 as a fraction here reduces. I can divide both of those by 5. So it's going to be 2 square roots of 5 over 5. That's going to be my sine of theta. Now, before you just take the final answer and find the reciprocal for cosecant, go back to the original and remember that if sine is opposite over hypotenuse, then cosecant will be hypotenuse over opposite. And if you go back to the original, then it'll be less simple, or less, you won't have to rationalize again. So 5 square roots of 5 over 10, and then 5 over 10 here, this fraction reduces to 1/2. So it's going to be just a square root of 5, or 1 square root of 5 over 2 for the cosecant. For the cosine, that's going to be adjacent over the hypotenuse. And then we're going to have to rationalize again. I think I'm going to simplify this first and simplify those 5. So I'm going to have 1 over the square root of 5, because 5 divided by 5 is 1. And then I can multiply both by the square root of 5 to rationalize. So I'm going to get the square root of 5 over, and square root of 5 times square root of 5 on the bottom is just 5. So the cosine is square root of 5 over 5. The secant is reciprocal of cosine, so that's going to be hypotenuse over adjacent, which will be 5 square roots of 5 over 5. Again, I can simplify. 5 divided by 5 is 1, so this simplifies just to the square root of 5. Then tangent is opposite over adjacent, so we will have 10 over 5, which reduces to 2 for tangent, and cotangent is adjacent over over opposite, so 5 over 10, which reduces to 1/2. So those are my 6 trig functions for that triangle. Remember that this video you can pause and go back and stop it in different areas. So if I went too fast, try going back and pausing it so you can make sure to get everything written down. So solving a right triangle means to find all missing lengths and angle measurements of the right triangle. So first, it looks like we are missing the measure of angle A here. So one thing you have to remember about a triangle is that the interior angles of a triangle have a sum of 180 degrees. So the interior angles of a triangle have a sum of 180 degrees. So that means when you add these up, so here we got 90 degrees, and here you don't know what this one is x degrees, or measure of angle A. So you know that measure of angle A, or x, plus 62 plus 90 is supposed to equal 180 degrees altogether. So really, if you did 180 minus, this would be 152 together, you would find out that x, or that's the measure of angle A, would equal 28 degrees. So we found one piece of our triangle is the measure of angle A, sometimes just used with the capital letter A, is going to be 28 degrees. And then we have one side of our triangle, our short leg is 6. We need to find the long leg B and the hypotenuse C. So we could use either one of these 28 degrees or 62 degrees to solve this. I'm going to let my theta be this 62 degree angle. So I'm going to label my triangle based off of that 62 degrees. So if I use 62 degrees, then B is going to be my opposite side, 6 will be my adjacent side, and C is always the hypotenuse, or the one across from the 90 degree angle is always the hypotenuse. So now I need to decide, I'm going to use Sohcahtoa, and I need to figure out how I can find B, the hypotenuse, and C, C the hypotenuse and B the opposite side. So if I know the adjacent side and I want to try to find the hypotenuse, I can use cosine, because cosine, I know the adjacent side and I'm just missing the hypotenuse. So I can say that the cosine of 62 degrees will equal the adjacent side over the hypotenuse. And now I have an equation with just one variable and I can solve it for C. So you're going to use the cosine button in your calculator. You just want to make sure that you're in degree mode. So you do need to make sure that your calculator is in degree mode instead of radians. Otherwise it will not give you the right answer. But we're going to solve this. First, I need to get rid of the C in the denominator. So I'm going to multiply both sides by C. That's going to give me C times cosine of 62 equals 6. Now I can solve for C by dividing both sides by the cosine of 62. So I'm going to get C is approximately equal to, remember your calculator does have to be in degrees, and so I got 12.78, which is approximately 12.8. So my hypotenuse has a length of 12.8. So now I want to try to solve for, so that was how I found my hypotenuse. Now I want to try to solve for my opposite side. So I need to use a trig function that uses the opposite side. And since I have been given the adjacent, I want to use the adjacent side as well, because that was my exact answer is adjacent. So which trig function uses opposite and adjacent? Well, that's tangent. So I'm going to use tangent to solve for the opposite side. So I could set up an equation and I would say the tangent of 62 degrees, because that's my theta, is equal to the opposite side, B, over the adjacent side, which is 6. And now I can solve that for B. And this one is one less step because I just have to multiply both sides by 6. And I get B equals, and 6 times the tangent of 62, again, your calculator does need to be in degree mode, is going to be 11.284, or I could say B is approximately 11.3. So B is 11.3. So now I've solved the triangle because I have the angle measurement and I have the two side measurements, and everything else was given. Using the calculator to evaluate, just practice this, pause it, make sure you're getting the right answers. Just be sure that your calculator is in degree mode. So when you do the cosine of 37 degrees, you should get 0.7986. Tangent of 12, you should get 0.2126. To do secant of 54, you have to remember that it's the reciprocal of cosine, so it's actually 1 over cosine of 54 degrees. And you need to type it in like that, 1 divided by the cosine of 54, and you should get 1.7013. And the cotangent is the reciprocal of tangent, so cotangent of 72 is 1 divided by tangent of 72. And if you do that in your calculator, you should get 0.3249, approximately. Okay. Oh, that's it. All right. You got to remember the acronym Sohcahtoa. Sohcahtoa. Or you could write it like this. So, because you can remember opposite over hypotenuse. Cosine is adjacent over hypotenuse. And toa, opposite over adjacent. And then for sine, you need to remember that sine goes with CSC. And cosine goes with secant, and tangent goes with cotangent. So those are the ones that, the reciprocals of that. So those are the big things for this unit that you really need to remember. Thanks for watching.